We all set? Okay, great. Okay, welcome back, everyone. Thanks to the generosity of the Russell Sage Foundation, the Alfred P. Sloan Foundation, and Duke University. It's my pleasure to welcome you back to SICSS, the Summer Institute in Computational Social Science. Hello to everybody following along on the live stream. I just want to reiterate for those of you who maybe are tuning in to this topic today on automated text analysis about how things work here and how you can access the course materials. So if you're on our website here, you can Google Summer Institute in Computational Social Science, which should be the first link that comes up. And if you click on Schedule and Materials here, you'll see we're now on Wednesday. And we're going to begin here with the slides for History of Quantitative Text Analysis. And we'll be following along both with slides and also annotated code that includes code chunks or worked examples with notes that explain how to perform all the things I'll be doing up on the live stream. And again, the point of that is to relieve you from taking notes. Okay, so let's begin with a history of quantitative text analysis. And before we do that, though, let me show you what we've got on the agenda for today. We are going to, after we talk about the history of quantitative text analysis, we're going to go over a bunch of stuff that most people don't know they need to know in order to do text analysis. These are things like character encoding, tokenization, stemming. If these words are new to you, this first part of the lecture is going to be essential for you to learn how to, essentially to learn how to transform words into numbers. Okay? Then we're going to talk about dictionary-based methods. These are methods where we have kind of a known subject we want to measure in a text, and we think we can measure them by counting certain words. Then we have our break. Then we'll go over both topic models, latent Dirichlet allocation, and a somewhat new variant of topic modeling called structural topic modeling. And we'll have another very short break. And then before lunch, we're going to go over text networks, which is a new technique, a new alternative to topic modeling for automated text analysis that's going to combine some new, more cutting-edge tools like part-of-speech tagging and sentiment analysis alongside some more conventional network-based approaches. Okay, finally, we're going to have a group exercise today where we all work on the same corpus of tweets and try to come back together either here at Duke or at your local institute to discover themes in that corpus. And tonight, not here, but at Kellogg, there's a live stream lecture by Ned Smith. He's a very interesting faculty member at Kellogg, the School of Management, who is doing really interesting work at the intersection of social psychology and social network analysis. Okay. So one of the things that really amazes me about quantitative text analysis is just how much was being done in the 1930s. We all like to talk about the latest and greatest neural net or Word2Vec or what have you. But if you do some digging, as I was inclined to do before I made this lecture last year, you discover that people like Harold Laswell, the political scientist, largely after the First World War, was writing stuff like this. We may classify references into categories according to the understanding which prevails among those who are accustomed to the symbols. References used in interviews may be quantified by counting the number of references which fall into each category during a selected period of time or per 1,000 words uttered. So in other words, this is, to my knowledge, the first attempt to quantify text analysis. Now what he's describing is somewhat primitive, right? Counting which words are uttered when. But on the other hand, many folks don't know that Laswell also had people hooked up to heart rate monitor machines and was measuring physiometric properties of people as they spoke. and measuring things like emotional activation around words. His interest, of course, in this initial post-war period was around propaganda. Later, as we'll see in the aftermath of the Second World War, security concerns also drove text analysis. So, ahead of his time, in 1935, and at the age of 21, Laswell was developing methods that tracked the association between words uttered and physiological reactions. Just a reminder that there are many who came before us. Or another great example is, as I mentioned earlier, the neural network, which now everything needs a neural net, right? Well, neural nets have been around since 1950. What's changed? Computing power, right? And so, of course, that has implications for how we work with text. But it's good to remember some of the genealogy of the ideas. And so let's take a moment to look at the timeline here. This is probably an imperfect effort. As you'll see, the timeline here spans many different fields, including political science, sociology, computational linguistics, computer science, information science, psychology, now machine learning, whatever that is, right? We can go back, actually some of the early pioneers, so Laswell is a political scientist, Gatsky is actually a literary theorist. Gottschalk, the psychologist, uses content analysis to track Freudian themes in texts. And of course, a big game changer was Turing in the 1950s. Some of the initial applications, actually some of the initial early development of AI, artificial intelligence, was in the realm of text, and especially text translation. Again, just by way of backstory, a lot of this had to do with the urgent need to translate foreign texts into other languages in the context of World War II and the aftermath of World War II. And so a lot of these early efforts were trying to train some of the first natural language models. Didn't really become institutionalized till 1952. We started to have textbooks about content analysis. People were slowly and gradually beginning to be trained in content analysis. 1954, we have the first successful automated translation of a text. 1963, again, some early political science pioneers use quantitative techniques to analyze the Federalist Papers. And again, more formalization of narrative analysis in quantitative format by literary theorists such as Tomaszewski here. And then we go into the 1960s and 70s, and what changes? Well, again, neural nets have been around. A lot of the principles of AI have been around, but computing power is changing rapidly, right? So Stone and Bales used the first, no relation, used the first mainframe computer to measure psychometric properties of text at RAND, right? And then there's a really big moment. So the famous linguist Noam Chomsky at this time is really producing what is viewed by many as a single theory of human language, right, that could be used to explain and interpret any utterance given universal laws of language, right? And at the same time, people are kind of figuring out that that might not be possible, that might have been a little bit of a reach, a general theory that could always infer the meaning of a text given its relationship or its adjacency, say, to other words, right? People continuously realize that in natural language use, words take on different meaning based upon their co-appearance alongside other words, and that words are highly context-based, and that there is polysemy, that is that words can mean different things to different people at different points in time, right? And here's where the field of natural language processing is born, alongside advances in computer science. The field of computational linguistics is born. The first part of speech taggers come on at large scale. And these types of things become used by political scientists and others doing automated event coding. Another big development is The linguistic inquiry word count software was created in the 1980s as an attempt to measure sort of universal psychometric properties of text. And finally, some exciting things start to happen in network analysis by Roberto Franzosi and others. And really, it wasn't until the 1990s that we started to talk about topic modeling. One of the classic papers written in the Journal of Machine Learning by David Blay. But around the same time, sociologists such as Peter Bierman, Jim Moody, John Moore are also developing network-based approaches for text analysis. 2003, we get more infrastructure like Mallet, which is a system, one of the early systems for running topic models on text. And then slowly and gradually, somewhere around 2010, when I was really beginning my career, you saw these methods just vault into the mainstream. Topic modeling, sentiment analysis, really started to show up in a lot of journals. In some disciplines earlier than others in social science, but really came to be viewed as a really major and important tool in the social scientists toolkit. And there was, at the same time, a bit of a hype cycle, right? So yesterday we talked about some of the strengths and weaknesses of digital trace data. And we talked a lot about how many people were arguing at one point that the size and the scale and the various strengths of big data meant that we won't need theory anymore, right? And we talked about why we don't think that's wrong. We think we might need more theory, right? Well, the same kind of thing is happening in text analysis. People are saying, well, now we don't need to read anything anymore, and now we don't need to. In the extreme version of this, now we don't need to do interviews anymore, and we don't need qualitative researchers, right? And now, those of us who have been involved in kind of bringing or trying to import these methods into mainstream social science have very quickly realized that these methods will not do that. The analogy I love is from David Blay. If you talk to him about topic modeling, he'll say it's a tool for reading, right? Machines are not yet at the point where they are going to do the interpretation for us. We, with some assumptions and with some patience, we can do great things, and we will do great things today. But we need to put some cold water on some of the hype cycle, and again try to reach the plateau of productivity that Matt and I have been talking about for the whole week. Okay. So it's an inherently interdisciplinary field. I'm sure I left some people out. If those of you watching or here have some additional events left out, please Slack them, and we'll add them for the website.